How do you test data workflows? This has been something that's really been stuck in the back of my mind for a while. To give a little bit of context, I've been a data scientist and I since transferred over to data engineering. And a lot of my focus has been on taking existing workflows and then putting them into production, getting it so that they can run reliably week after week. And this is scary. I have had times where I've been woken up at 3 in the morning because a critical workflow failed, and it's because I forgot a close parenthesis. Not fun. This is a solved problem in a lot of other processes where you can test your code and you can have all sorts of unit tests, integration tests, etc. And you test that before you put it into production. But how do I unit test a SQL query? What can I do? There was this really good article by Eric Bernardson that I'm just going to go through this entire quote because I think it really gets to the heart of the matter. I'm writing this somewhat apologetically, maybe with a sense of guilt as I'm admitting some dark secret. I'm a big proponent of very thorough testing, but getting any reasonable amount of test coverage on the data side is hard. On the data side, the state space is huge. This means any unit test basically ends up being 99% just setting up all the input data. But because the input data is super high dimensional, it also means modeling edge cases becomes exponentially harder. I like to have a few basic tests to make sure things run, but verifying correctness might not always be worth it. I think you need a different approach to testing data workflows. I think the architecture is very different. If I'm going to have a very simple model of a data workflow, it's going to be SQL, maybe some machine learning. Maybe you have some data scientists on your team and they're going to do data frames instead of SQL, but SQL is just going to be all over the place. Your code is going to be much more focused on scripts or notebooks. You may have some functions as a part of it, but you're not working with lots of interacting classes. It may take a long time to run a process. You may have hour-long SQL queries. Perhaps you can look over a much smaller subset of data to see if that runs, but that might not always be the case. And so it's very difficult to be able to test and check. Your data processes may have some dependency relationship between things. You'll have a DAG between scripts, and that's a very critical part of your infrastructure. And finally, the way I see people testing and demonstrating in a pull request that this is a valid change is basically, I ran this, look, it's a successful run end to end, here's the diagram or here's the output, and maybe they've done some exploratory data analysis to say that the data they generate looks good. I think the risk model becomes different. With object-oriented programming, you've got lots of interacting classes and you need to be able to really look at kind of ways they interact together. Contrast in data workflows, I'm building a big SQL query in my Postgres client, and then I know it works there. I copy paste it, and I forgot the select part of my query. Or my cat walks on my keyboard. This is Coltrane. He loves to let me know when it is lunchtime. Or my data concept is wrong. As a part of talking about data testing, I think it's worth bringing up what CI/CD is. CI/CD stands for continuous integration, continuous deployment. There's a lot of philosophy around this in the extreme programming. General idea, everybody's working on the same code base. So if you're using version control, you're continuously integrating, good job. But in practice, a lot more of the discussion becomes, how do we get everybody to easily work on the same code base? And as a part of that, you ask, what parts of software development can we automate? What can we automate? So on the continuous integration side, which tends to be more everybody working together, you can automatically run your code tests every time you run a commit or push to GitHub. You can have data tests. You can do things like linting your code or scanning for passwords. On the continuous deployment side, which I won't get into so much, there are things like putting your code in the prod server, making your documentation. If you have a package, putting it on pip-audit. So I think the question of how do you test data workflows, I think can more be turned into what can we feed into a CI system? What can we automate around our data processes? And as I've looked at this, I think there's kind of a three-pronged approach we can take to this. There's the traditional testing approaches that you will see and you know and love. There is static analysis, and then there is data reliability. Traditional testing. There is a very robust tool chain in Python for writing unit tests, writing integration tests, mutation testing, et cetera, et cetera. I'm not really going to go into too much depth into this. I highly recommend, if you get the chance, to watch Raymond Hettinger's video of preventing, finding, and fixing bugs on a time budget. He really goes over kind of a good set of testing strategies. If you're interested in learning PyTest, there was a great tutorial here at SciPy 2019 by John Lehman and Ryan May. And Zach Hadfield-Dodds has been doing some great presentations on property-based testing. But I'm going to take a simple data process like this, where I load some data into a data frame from a CSV. I'm doing some data transformations. I have this Hodge Lehman Sen operator, which estimates a pseudo median for my data. I have some aggregation, group by, and then I export my data. And the question around this is, what would we feed into PyTest? Kind of the way I see it is that I'm using a lot of pre-built tools as a part of this. And I'm going to trust that the folks behind Pandas, NumPy, Editor Tools, they're doing a pretty good job in testing their work. What's more unique in this is my implementation of the Hodges Lehman Sen estimator. And I think this is what I would want to focus my testing on. Anytime you are creating unique data transforms or creating your user-defined functions, that is something that you can move into its own module and then feed into PyTest or any other process. The other thing you can try looking into would be more end-to-end testing, an integration test, or you might call it a bit more of a smoke test where it just didn't run without breaking. If you're going to create some data you want to feed into this, there are some options for generating fake data. The SciPy stats and scikit-learn data sets are pretty good options for generating random data if you need to follow some statistical distribution, if you need to create blobs. If you're trying to create more realistic data, things like names or addresses, Faker is a good library for generating a lot of that you can feed into your system. You can also look into some services like Mocru and generate data. Additionally, some orchestration systems like Airflow and Prefect are based in Python, and they do have some options for letting you test the DAGs that you're building as a part of this. And lastly, I think this is a little bit of a hack, but I think this is a way you could unit test your SQL queries. Some SQL engines, not all, but things like Postgres and MySQL have the option to do explain plans, where instead of running a query, you take your query and you prepend it with the keyword explain. And what it does is it doesn't run it, but it tells you how it would run your query. This is a very useful tool if you're having a very slow running SQL query and you want to understand, how can I optimize this process? What can I do to make it go faster? But also, if you have an invalid query, your explain plan would fail. So you could scan through your code, grab all the select statements, prepend with explain, and then feed that to your SQL engine and see what happens. In practice, I have not found this to be as helpful as I'd like. You would need your testing system to be able to have access to your database. It's a little bit of a bodge. It's also not available in every SQL dialect. So, neat trick. You may find it helpful. I don't know if it's truly a panacea, though. Next option, though, is static analysis. So static analysis is a kind of test that doesn't run your code, but just looks at your code. You may already be doing this. If you're using an IDE like PyCharm or VS Code, and it gives you those little squiggles that says, hey, you're using a variable that you haven't defined, or something along those lines, that is a static analyzer at work. Now, static analyzers are weaker forms of tests. They don't test any logic. They're very limited in what they can do. But with this said, I can throw all sorts of things into a static analyzer and it will just run through it. There are a bunch of commercial options for static analysis. I think it really had a heyday kind of the 90s and the early aughts. I do think a lot of the commercial options for static analysis are focused more on the object-oriented programming. But there's a lot we can pip install, and I think what we're able to do captures a lot of my interest. First thing I will recommend is a tool called pre-commit. I think this is a really fantastic tool. If you're unfamiliar with the concept of Git hooks are little bits of code that you can run before or after different actions in Git. And a very common one is to run pre-commit step. Unfortunately, Git hooks are really difficult to work with, don't have great cross-platform stability. Quite often people will do shell scripts, which works in a Unix-like environment, but not in Windows. And so Anthony Sawtelle, I think his last name is, made a hook manager called pre-commit, where he has a whole list of pre-written Git hooks. You simply create a YAML file that says, these are the hooks I want. Pre-commit installs them. It works great across lots of platforms. And then every time I run git commit, it's going to do checking my code against the hooks I provide. And this is a great form of static analysis. So a very simple question we could ask is my code valid? Is this a parsable Python or parsable R or parsable any other kind of code? If you're looking at Python, you have the check AST hook. Is this valid Python or not? And so if I accidentally dropped my close paren, it would catch that. If you have important configuration in YAML, TOML, JSON, XML, it can check those as well. Another thing you can think about is not important configuration files aren't just any sort of JSON or YAML or something like that. They will have a well-defined schema. And you can go to schemastore.org and you will find a bunch of different JSON or YAML schemas for a number of configurations. There is a check JSON schema utility, just install with pip, and you can use that to see if your file actually matches the schema. So in this example, I have Argo is a orchestrator tool where you define your DAG and YAML, and I can see, does my Argo YAML fit with the schema or not? And if it doesn't fit, it will tell me where the error is. This has a hook with pre-commit. If you're working with XMLs, for example, if you're using Uzi as an orchestration system, there's the XML schema pip-audit utility. Sadly, no pre-commit hook yet. Another thing you can look at is linting. Linting is basically just reformatting your code to adhere to some style guide, be it pip-8 or something, or black, something like that. isort is an option for sorting your imports based on some logic they have there. These all have pre-commit hooks. So if you want to just have a very consistent style for formatting, sometimes linting helps you catch errors. It's a helpful way to go about doing this. One bit of caution I will have about linting, though, is you don't want to lint other people's code. If you're starting with something a lot of people have worked on, and then you just throw it into black or something, whenever people run git blame or git annotate, they will just see whoever changed each file last, and it's probably going to be this person just put it into black formatting. And so if you're trying to understand why somebody did something in a code change, that's going to really interfere with that. There is a library called Darker that only applies black to regions that have changed since the last commit. And this has a pre-commit hook as well. So you can incrementally start linting your code as you're going through and working on things. Related to linting, there's a great library called SQL Fluff. Another pip tool, or another tool you can install via pip, it handles parsing and linting SQL. And it has a pre-commit hook for linting. If you run this as parse or lint, it will return an error if it finds parsing or linting violations. And so I have personally found this to be very analogous to check AST. Is this a valid SQL query or not? This is slightly off-label use for SQL Fluff. SQL Fluff's goal is more properly parse and format good SQL queries rather than filtering out every bad SQL query. But they're very amenable to pull requests if you ever run into an issue where this SQL Fluff is letting this pass, but this would not actually be a valid SQL query for a given reason. Another thing we can do for static analysis is security testing, sometimes called SAST. A lot of Git providers will actually give you some option for SAST. GitHub and GitLab have SAST scanners. Sneak as a commercial option is a good one. It's actually a good idea to use multiple static scanners. Each scanner is going to have a rule list of things that they look for, and the rule lists may be slightly different. So if you just throw your code into a few different scanners, you may be able to catch a few more additional issues with your code. Probably the most common SAST tool in Python is a tool called Bandit, another pip install. I realize the code's a little small and unreadable, but I passed some code into Bandit, and it found a couple errors. It found a potential SQL injection attack, and it found YAML using YAML load, which can execute arbitrary code and can also be vulnerable to YAML bombs. Some of this stuff is things I wouldn't have known about. I had never heard about YAML bombs or XML bombs until I started working with SAST scanners. And very easy to use, has a pre-commit hook. Secret detection. Do you know that if you go to GitHub, and you just go into the search bar and you type remove password, and you look for commits, you'll probably be able to find people putting their passwords up on GitHub and then removing them, and then having a commit message, remove password. It's very easy to look for. More to the point, people will be scanning the APIs for GitHub, GitLab, etc., and looking for anything that looks like a potential password. I think they've done some research on this and found intentionally putting a password for a service on GitHub, people will pull that in a couple of minutes. You really want to be very careful about not putting passwords or other secret information in your Git repository. A good tool to help you with this is a tool called Gitleaks. It has a number of regex rules that it looks for different passwords, and you can also set it to do substring entropy. Look for long, randomish looking characters. It's not a Python package. It's written in Go. Installation is a little bit more complicated, but it does have a pre-commit hook, and I think it's a very helpful tool to add to your tool chain. If you are handling secrets, I would really recommend looking into python.env, or .env has kind of become a standard across a number of different languages, where they'll put your passwords in a .env file, you'll add .env to your git ignore, and then python.env or whatnot can load your secrets from there, or load your secrets from environment variables. Package security. You probably have seen this Dependabot alert if you're on GitHub. It'll say, hey, you need to update this package. And GitHub will often even give you a nice pull request to just, please update this. Okay, merge pull request. It's very important. And there are a lot of concerns that we're starting to see around Python packages. First bit of advice I would have is pin your dependencies. Be explicit. This code uses this version of SciPy, this version of NumPy, this version of Flask. This helps these security scanners see if you're using insecure versions of code. Also, We're running into more supply chain attacks. As I was preparing this presentation, we saw a malicious package uploaded to PyPI. Thankfully, it looks like PyPI is now requiring two-factor authentication around a number of important projects, so that will help guard against that. But this is a concern. If you are interested in some package security and you're not going to be using GitHub or GitLab for that, I might recommend a tool called pip-audit. There's a database, the Python Packaging Advisory Database, that lists insecure packages and why they're a problem, and pip-audit is able to look against them. The one concern is it does install things, so if you have these malicious packages, it will run into some trouble around that. But hopefully, pinning your dependencies, you should be able to be careful against that. It also has a pre-commit hook. Last thing to look at for testing is more data reliability engineering. Your machine learning models are only going to be as good as the data that gets fed into them. There are, I think, two ways I like to think about data reliability engineering. Either you're going to set some fixed rules around your code, and number of tools around this like grade expectations, PyDQ, DBT tests, or you can have more of a statistical process control approach where you want to monitor your data over time. Now, there are a lot of things you can measure for your data. If you have 10 columns, you could measure ranges, you could measure standard deviations, means, and all that. You can quickly run into an issue where you start getting lots of false positives and you don't know what to do about them. Monitoring data volume, freshness, and acceptable ranges is probably a good start. And then my recommendation is, as you run into additional data errors, then you can start adding tests from there. But it is very it is very easy to run into paralysis by too many potential alerts. On the static rule set, grade expectations is a package I've seen recommended multiple times. Basically, you'll define some set of expectations for your data in a JSON structure, and they have over 200 pre-made expectations. This package will talk with a bunch of databases. The grade expectations kind of offers their product as a service if you want to run in the cloud. And you can also have fixed rules, like this data cannot be null, or you can offer range of values, like 10 to 20% of this data can be null. But one issue that you will see is that fixed rules are fragile. What could be an anomaly could just be, we created a new sensor network and now we're getting twice as much data. And so you'd have to update your rules as all of these things happen. A more robust approach is basically to look at your metrics over time and try and create some statistical distribution of what you would expect the values to be, and then see, are you outside of that statistical distribution or not? Sadly, I'm not aware of any good open source packages for this. SPC is pretty common industrial utility, but a lot of it tends to be, we're just going to assume that this data is normally distributed and it's not really going to change too much over time, which honestly I don't think is a very good way to represent how data moves. I'm not expecting much Brownian motion in my data. I think there are a lot of subtleties involved in looking at anomalies for data. This is a case where I might actually recommend, if this is a critical issue, looking more into some commercial offerings, and we're starting to see companies like Anomalo and Big Eye get into this space. And so if this is critical, I might actually recommend doing that. So, summing this up, I think there's different approaches for testing this, and I think they really have different uses. Where you're creating your own UDFs, where you're trying to test data transformations, if you're using a Pythonic DAG, that is a good case for unit and integration tests. Everywhere else, you can try and throw static analysis tools at it and catch broader concerns. And then, where possible, data quality checks to make sure that what you're feeding into your models is good. But one last note. These are general suggestions. This doesn't have to be Python. Some of these tools are language agnostic. Other languages have their own tool chain. I've had to work with a lot of data workflows that are in R, and R has some pre-commit hooks as well. It's got parsing, it's got linting, it's got package security. It has some static analysis, but sadly no SAST. And I think this would be a really good opportunity. I say not being the one doing the work, creating these, but I'd love to see more static tooling available for other data languages like R, Julia, MATLAB, Mathematica. I think there's some real opportunity there. Thank you very much for your time. If you need to get these slides, you've seen there's been some hyperlinks as a part of that. They're available on my GitHub IO page. And thank you very much.
Alrighty, at this point, we'll go ahead and open up for questions. We do recommend that people ask questions in the Track Questions - Grand Ballroom channel. So do make sure to post your questions in there. I see we already have one in here. So from Patrick, thanks for the presentation. You mentioned the difficulties around testing SQL queries since the test might not have access to your production database. One alternative might be to mock the database via in-memory database during testing and run SQLs against the database. Do you have any recommendations about how to do this or advice why not to do this?
So if you're in a place where, say, you've got SQL Alchemy generating your database tables, and then you can go from there, I think that would be a better situation. And then I think you can try looking a little bit more into that. For me, I've not been in that situation. I've largely been just here's the data engineering teams. They have their ETLs. Here are all the tables that we have. I was working in Spark where there wasn't a really good ORM solution that defined what all the table schemas were. And so you just sort of had to work with what you had.
Great. Next question from James. What's your opinion about enforcing a minimum test coverage threshold in CI for Python projects? So
I'm very into data testing to the point that I joined CodeCov, which is a data testing company. I'm not going to necessarily say any minimum threshold makes sense. I think it's going to be very context dependent. If you have just a bunch of SQL queries, how easy are you able to even say what your coverage is? If you have some mix of user-defined functions in SQL queries, you can look at that. You'll have to just gauge your own risk about how bad you think things are going to be and how miserable you'll be at 3 a.m. if things break.